right. Week 4 already, almost halfway through our 8-week format. Okay. Yeah. Get right to it. Going to go over some writing tips. I know some of you are not happy with my feedback, and I understand. So I'm going to go over things again, and I hope I'm being clear. That's the main thing. Is I think I've made my expectations clear. I think some folks are either not listening to my lectures, not reading the announcements, um, or are hoping I'm bluffing, or hoping I don't read your assignments, and that things will just go through like you might have with previous instructors. Not everybody spends the hours that I do grading and providing feedback and whatnot. So this week, yeah, it's we're talking about traditional analytics, data mining, and then there's an interesting research paper I'll go into specifics on regarding future research opportunities in big data. And as I've said before, remember, you are in this program to become researchers, not just to get another advanced degree. So you'll also see, I believe it's the literature review in this week's classroom content. Let me go to this week real quick. I want to make sure that you have supplemental, the literature review. Dr. Brown posted some information about writing a literature review, what they are. If you go out on Google Scholar, you'll see there are these things that review previous studies and put them into context and group them and describe them and summarize them. And they're fantastic sources of information about your topic. If you know what you're going to go into for your dissertation, just what area, whether it's cloud computer security, or for me, it was enterprise social media. Um, and like knowledge loss and turnover and that sort of thing. So I was able to find a few literature reviews that led me to a lot of really great sources. So you will see that supplemental section in the week 4 folder, or if you haven't already seen it. And the university decided to reiterate the academic honesty pledge. We're seeing it every week in class discussion. I'm seeing it in papers. Folks are just not writing 100% your own stuff, even basing, you know, your writing on the exact structure of someone else's things. Like, if you find a website with 5 bullets on it for the benefits of analytics in healthcare, and you use those same 5 bullets and you basically say what they say, I'm sorry, that's still plagiarism. You need to write freshly. Think about adding just fresh stuff, fresh knowledge out there, and you'll be okay. Okay, so yeah, we got a discussion in a paper again this week, and these 8 weeks formats are action packed. Okay, so writing tips. I'll say it again. Start from an outline. Jot down your thesis sentence. Even some of the most excellent writers in the class that really understand these topics and write really well about them are forgetting that that high school level clarity where you have an outline and you have a thesis sentence that says, I'm going to cover, say, for example, benefit 1, benefit 2, and benefit 3. And then you have developmental paragraph or paragraphs. The first one is benefit 1. The second one is benefit 2. The third one is benefit 3. And each one of those paragraphs has a topic sentence. Benefit one is a benefit because, X, Y, and Z. So that it flows and your reader is led by the hand through your topic without a lot of jumping around or harsh transitions, as they're called in academic writing. You want to flow smoothly and logically from topic to topic, and that's impossible to do if you are either, you know, pulling up a Word document and just writing from the beginning to the end without constructing your paper first, like I tried to advise in my week one academic writing lecture. Top down structured design. You wouldn't just start blasting code out. You would start thinking about what modules you needed and what functionality and what the requirement was. So um, some of you, if you've watched my academic writing for systems engineers video, some of you are not taking it to heart. So the problems I'm seeing is you're either not, if you're not getting the score you want, you're probably not using an outline. And then some of you are assembling sections of your paper kind of from what you see on other websites or in other papers instead of creating your own flow based on, um, I don't know, maybe 4 or 5 hours. I would think you would need a background reading just to get these topics into your head. So I would say, 4 or 5 hours, and then another 4 or 5 hours to plan and write the paper. Some of you can do it in less than that, but that's about what I think it requires. Um, and then similar or maybe a little less um, for the discussions, which is tough. If you guys are taking 2 8-week classes, yikes, that's an awful lot. So anyway, start with an outline, not something else, and then work on it. I had a student tell me that. I pasted it into my paper. I was still working on it when I submitted it. That's just not the way to go about it. Don't bring anyone else's words into your paper. It's an infection. It's an invasion. It's problematic. Don't do it. I'm seeing it, and I'm telling you, don't do it, please. I have provided a seventh edition APA paper. It's just a sample paper. It's to show you heading levels and whatnot. And yeah, I've also found a cheat sheet for formatting. I have asked all of you, and no one has replied, to explain to me where you saw using a colon at the end of a heading on at least 4 or 5 of your papers. I said, where are you getting this? I've never seen this before. Why are you using a colon at the end of this heading? And none of you have replied to me. I wonder how you would feel if I ignored your emails for days on end. Anyway, it's not APA format, best as I can tell. Don't put a colon at the end. That I've seen that paper on Course Hero. I see that same paper semester after semester after semester with the colon at the end. And that's, those are one of the many telltale signs that you're not starting from scratch. Anyway, and in discussion, I told many of you you're posting a mini lecture. There's too much of that. There have been some good actual substantive discussion posts where people replied and wrote something to the other person that actually took into account what the other person said, like a discussion, that was good. And then some of you smack return and say what analytics is the analysis of data and other similar just not adding anything. It's not adding anything to anybody. It's not helping anybody. It's wasting my time to grade it. It's wasting your students' time to read it. Your classmates' time to read it. So please stop. Uh, I'm not looking for PhD level writing and academic rigor and whatnot in your replies to fellow students. I'm looking for discussion. And if that is too difficult to understand, shoot me an email if you don't know what a discussion is, and we can talk it over. All right. Let's see. Next. Oh, an outline. Folks, I think we learned outlining in middle school, if not before. Okay. It's top down structured design of a paper. Okay. You introduce your topic. Um, and in that introduction, you will lay out what you're going to say about that topic because you probably can't say absolutely everything about a topic. And that is the point of the thesis sentence. The thesis sentence describes the intent of the paper, the overall thesis of what you're going to say. So, for example, uh, for this outline, thesis sentence might be this paper will describe how radios work, their use to generate revenue in the radio industry, and the specific uses um, of the technology to date, or something to that effect, so that you've got topic, how radios work, radio industry, and uses. You've got that spelled out in your introduction, and then you stick to that. And then each one of those would have a topic sentence, you know. So anyway, this and guys, I'm not an English professor. This stuff is all over the internet. It's just basic writing. Um, just just embrace what you've been taught. Uh, yeah, an outline, not these. I see same these same papers from Homework Market seems to be a new one. Course Hero is horrible. Course Hero has I think we're up to hundreds, if not thousands, of your classmates' papers posted. Um, and it's like posting the questions from the bar exam for a lawyer. It's not ethical. And I want to say I've had Narendra Reddy Kudumula in a class. Uh, so anyway, yeah, I hope you're not doing this. I hope you're not using these sites. I hope you're not sharing your work there. Um, uh, this program is going to fail miserably if there's not a significant and rapid cultural shift in the way um, this sort of thing is viewed by the student body. Okay, so enough about that. Uh, as always, email me with any questions or concerns. So this week we're doing two things. We're talking about good old fashioned traditional analytics versus data mining. And I've got a little bit of personal experience in both of these somewhat. So I'm going to give you my thoughts. They don't necessarily aren't necessarily exhaustive. I don't claim to own um, exclusive right of definition of these terms. So I'll share what I've learned, and then I'm going to go over the assignments for this week and see what you guys have learned. Okay, so as you see it defined all over the internet, and no one owns these terms. That's kind of one thing that leaves them to evolve. Analytics. You hear, analytics. I've got one employer I work with. It calls it informatics, analysis, business intelligence. You just there's just so much overlap, but um, traditionally, uh, analytics are being done on like I would say newly occurring structured data, so that you can see where you're going and answer the same business questions that you always want to answer, like every month. What was our top selling product? Who was our best salesman? Or maybe a daily analysis. Um, the bed utilization rate at our hospitals? Are we at 60%? What's our usage on ventilators, in the COVID area, those sort of things. So these are, traditional analytics use relatively structured data to answer relatively routine, mundane, repeatable um, business questions throughout, you know, industry verticals and functional areas. So it's just kind of, your good old fashioned running the monthly report kind of thing, or even like a current real time dashboard that's, updated every second, by um, could be like, UPS or FedEx or one of those companies that or even a cybersecurity security operations center that's looking, at data in real time. But they know what they're looking for. They know what their data looks like. They know what the data can provide for them. It's just a matter of now using tools to get that in front of decision makers. So to me, that's traditional analytics. Now I have had uh, one great big data mining project I was in charge of. But it's been years. But anyway, I'll talk about that in just a little bit. So data mining um, got its start as a term in the 90s, and it kind of came around um, as information systems and PCs and mainframe computers all began to grow and grow and grow and grow in use, and you started to see the beginnings of, if not the formal declaration of, the big data era. So data mining is kind of like regular mining. Okay, so the like gold mining or oil mining, um, which is usually called more like exploitation or exploration or drilling, pumping. Anyway, let's use gold mining. So gold mining, uh, they kind of know geologically where gold is likely to occur, and it's similar in data. The data is going to occur on a computer somewhere. So there's, you're not looking out in your front lawn when you're doing data mining. So a gold miner goes out into the wilderness with a pan and scoops up some gravel from the bottom of a riverbed, because that's normally how gold is washed down out of granite deposits, and the motion of the water tends to bury it down to the bedrock level of a stream. Um, so that's where they go looking to see if they can actually find some gold flakes. That's where the term, you might have heard, that just didn't pan out. If some idea didn't pan out, that's referring to a gold prospector back in the old days using a pan to see if there are gold deposits somewhere. So in the data world, it's kind of like that. It starts like that. You're looking for um, correlations, relationships, interesting clusters of data. and the way that the data relates. It doesn't necessarily, when you're going in data mining, you're not necessarily asking a specific business question like in traditional analytics yet. You're really just going out to see what it is we might be able to learn from this giant pile of data. Kind of like that. At least that's the way I understand it. Seeks to find relationships and information in large and normally unfamiliar data sets. So I use the word perhaps. And big data has just made it if you toss in the unstructured data, the social media stuff folks are tapping in, and video and audio data, and then somehow relating all of that in a structured way, um, to find the gold nuggets of information among the rocks. That's, to me, that is data mining, and huge challenge, but man, they're getting better and better and better at it. So that to me is the difference between analytics and data mining. Data mining is kind of preliminary to analytics, and analytics is more like production. Like, we found the gold ore seam, and we got the gold out of the mine, and now it's time to process it and turn it into jewelry. I guess the analytics, I would consider everything that happens after they get that gold out of the ground, and mining is just that. It's finding and retrieving the worthwhile, the data that has value. So there you go. And there's more examples of that than we can go into. So if you're going in looking for correlations, hey, one of the best things you can throw up there is a scatter plot matrix, and these can get really huge. But that's, like, to me, that's your most elementary way of looking for correlations among multiple variables or elements. This only works, of course, if it's basically continuous and structured data. But it shows you, this is actually a data set on flowers, irises, I believe, that you can find out there on, like, GitHub. It's good for practice data. I think I pulled this plot out of Seaborn using Python, which the Seaborn library is kind of like an extension of a library called Matplotlib. Some of you guys know all about this. I saw in the class discussion. So anyway, that's an example of data mining. I didn't really know what question to answer or to ask, so I just threw up a scatter plot, and now I'm starting to see correlations over. Now I can start to look at this matrix, and I can look at the way data is clustered and the way it correlates, and I can start to wonder why that is. What's going on here with this data? And data mining it's iterative, it's exploratory, it's not elementary, it's not foundational, it's not entry level. I don't believe. I think it's kind of a next level skill set. And then, for instance, you got a whole bunch of text. A word cloud is not a very quantitative measure, but it gives you an idea of, if you had 5,000 pages of text and you had no idea what that text was about, you could run a word cloud, and it would start to help you. And then the underlying metrics of the word cloud, where it gives you the no kidding word count, and derivations of the word, variations of the word, and whatnot. That starts to give you some bibliographic quantitative data, as we learned in the 3F method. So yeah, my experience with data mining goes back to 3 years I spent at the end of my career in the United States Air Force. I was responsible for all of the records, emails, information papers, PowerPoints, uh, um, everything. I was basically the it's called the records manager. I was the uh, uh, command records manager at a U.S. CENTCOM, which is the headquarters for our military efforts from Egypt east to Pakistan, including Central Asia, Afghanistan, Iraq, all of that, uh, um, the Saudi Peninsula. Anyway, so yeah, from 2009 to 2012, I was the command records manager, and I was responsible for policy and training and compliance with managing all those records. And we were getting requests for information, formal requests for information through the FOIA process, Freedom of Information Act, um, constantly. So we had to, try and do good record keeping, trying to manage email as a record and actually filing an email according to its disposition and deciding how long you're going to hold on to stuff or how and redacting. This is all most of it was classified information. It was just incredible. And then so that's a 5,000 person headquarters in Tampa, Florida. So all 5,000 of those people are on a computer all day every day writing uh, records, things, emails, papers that were, critical to national security and of historical significance. So we had a huge information management challenge on our hands. And then over in Baghdad, for example, you had a headquarters of about 1,000 people doing the same thing, sitting at computers, reading and writing emails, writing reports, writing contracts for reconstruction, creating operations orders for troops in the field to go handle, making supply orders, all of this digital records, right? So for years, they're the main headquarters in Baghdad that we were responsible for. It was a subordinate business unit of my organization. When the withdrawal came, um, we had uh, 47, I think, terabytes that we had to bring. We had to fly a storage area network back on a cargo plane, on a pallet. That we had moved this storage area network from network control center around to about 4 or 5 different network control centers, and basically copied everything they had. We had, no kidding, relational databases. We had entire SharePoint websites. But then the main thing was traditional file shares, just a network file share. And you hand that over to a bunch of workers and let them create their own file structure. And oh my goodness, it quickly filled up with very important gold nuggets of files, to junk, to letters home, and duplicate data, and pictures that people took, and because it was a combat zone, there wasn't all that much control necessarily, and some people would load music files onto the share drive so that they could play them through their computer speakers. And as long as, I mean, these people were working 12, 18-hour days, and there wasn't a whole lot of oversight on the network because of the operating environment. So we brought all that home, and it was on, I don't know, I think we had like 18 different drive letters that kind of represented different levels of classification, um, and different sub operating units that had their own shared drive. It wasn't just one um, central IT organization, and we had no use of Hadoop or Spark or you know, cloud-based computing where we could, expand. None of that. We all we had was this storage area network, and it took days to comb through, and not and we never even did get a fully indexed. The index for that uh, um, text mining operation would have been enormous. So we used a tool called Active Navigation, Active Nav. It's still out there on the market. And we started looking for mining for common keywords and common metadata like file names and dates and folder names and dates and how things might have lined up. The idea was we needed to fully refine this collection of data coming back from Iraq, just like you would refine gold or oil, so that we could turn over um, historically significant actual formal records to the National Archives, for permanent preservation. I mean, this was our nation's history. So if somebody uploaded a picture of their kid from home that got emailed them to them, we tried to find all of that. There was a lot of personally identifiable information, stuff that didn't really belong on that shared drive because it was stored officially in maybe like an HR system or something like that. So there was just yeah, we worked on that for years and I retired. It was just monumental. And uh coming back from Afghanistan, it had to have been even worse. We were working with um the uh the process in Afghanistan, or the headquarters in Afghanistan, and that was even more complicated because you had U.S. records that I had oversight over, but it was a NATO operation. Really, the U.S. was over there under NATO auspices, so drawing the line between a U.S. record and a NATO record, and then the difference between joint records or something that belonged to the Army or Navy, it was just a nightmare of information management over there. So anyway, that's my data mining story. Thank you for listening. Some useful links here to get you going on your research paper and your discussion. Um, I just typed in differences between data analytics and data mining, and we got a blog, iMarticus. You're welcome to read that to get your thoughts flowing. The folks at SAS had a piece on that you might find um, interesting. And then I saw one on Code Motion that had some interesting thoughts on the difference between traditional analytics and data mining and what is data mining. Okay, so you're welcome to read those. I don't want to see their words, in your posts. If you want to piggyback on a thought you see there, all you do is cite the source. Oh, when it comes to citing a website, in your papers, you really want to use journal articles and cite them very often, like uh, the library database will have a link that says cite this article, and it has the citation in perfect format. You download that and add that to your bibliographic software, or Google Scholar will have a download the citation and add it to your bibliographic software. That's the way I would go if I were you guys. I wouldn't want to get anywhere near my dissertation and not have bibliographic software up and running and working and all that. But sometimes you run into a website that you want to cite, particularly in class discussion. Um, your committee may not allow you to cite anything that's not a peer-reviewed journal article or a very reputable site like Gartner or Pew, something like that. Um, so for class discussion, there's a thing called a citation generator. I mentioned this in a few of your papers. I just Google it. Find one that you like. I don't even know if we have one in the at the university library because I don't think it comes up when you Google it. But anyway, if there is, toss a link into the class discussion. I think would that'd be or email it to me. Anyway, there are citation generators out there where you type in, the title of a web article and the author and the date and whatnot, and it generates an APA reference and a citation for you. So I would use those if you're going to cite a website. Okay, so on to the assignments for this week. Um, your week 4 research paper. This one, I want to offer you to shorten the length of your paper. For one, I hope everybody hears me this time. I've mentioned it before. You don't need a table of contents. You do not need an abstract for my papers. Okay, so don't use your time creating those. You do not need a table of contents. You do not need an abstract. Okay, I got 3 or 4 of those, so I want to make sure those folks realize it was above and beyond the call. Okay, so there's a paper to read about the uncertainty of big data, and um, the author has some recommended future research, and that is something that you'll see in many, 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 many journal articles, and those reputable authors recommending future research is a great way for you to describe your literature gap by citing multiple authors that have recommended further research, and in recent articles, of course. That is a great way to frame your literature gap in your dissertation. So if you're not familiar with that, check it out. It's a big part of your dissertation. Okay, so you need to browse that paper, look at these areas, but I just wanted to go over each of the 6 choices, right? 1, 2, 3, 4, 5 choices, and what we're looking for. Now, I want to say 2 to 3 good pages on these topics will get you an A. 6 pages of background, unrelated, rambling stuff won't get you an A. Okay, so I'm inviting you to shorten your paper, to condense your paper, so that you are not tempted to just fill in space, because 6 pages is a lot to answer these specific questions. These questions are pretty specific. So if you write specifically, accurately, concisely, with precision, you can knock these out in a couple pages. All right. So we'll see who's listening. Okay. So we're supposed to look at 1, 2, 3, 4. Yes, 5 bullets here. Okay. First one: additional study must be performed on the interactions between each big data characteristic, as they do not exist separately, but naturally interact in the real world. Okay, so remember our big data characteristics. So how how do, like, say, volume and variety interact? That they, and so if you're out there on Google Scholar, maybe you're looking for interaction of big data, volume, and variety, and using keyword searches like that, so that you're looking the way the three V's or the five V's, how those um, um, characteristics of big data, how they affect each other, like like the correlation of them. How does volume correlate with variety? Or maybe it doesn't. I mean, you can have a huge volume of very structured similar data. So the variety and veracity, maybe, it gets harder to assure the veracity, which is the quality of the data, um, as your variety increases. I don't know. Check it out. Do some, like I said, scan the article, pick one that sounds really interesting, and then do your best. And a couple pages would be good. Okay, and scalability and efficacy of existing analytics techniques. Um, Now that's um, could lead toward, like uh, um, Hadoop and Spark, but not really, because those are just ways of dealing with the volume. Those are really just dealing with volume. So um, perhaps you can find some discussion on different ways, like data mining versus traditional analytics, or something to that effect, or AI. Um, so, at what point is our existing analytics no longer scalable to look at, petabytes of data? So, you check that out. New techniques and algorithms must be developed in machine learning and natural language processing to handle the real-time needs for decisions made based on enormous amounts of data. Okay, that's uh, that's true. Particularly, I guess, if you had access to um, unstructured data that was in text, like maybe on January 6th this year, and you could possibly be looking for dangerous situations to occur. Uh, you know, anyway, there's whenever we're talking about big data analysis, there's always, it's like any other technology. It's like nuclear power. There's always a concern and an application by government that makes it potentially controversial. And I see it all the time when we talk about data science, um, and privacy and whatnot. And who's got the data, who can get access to the data, what can you learn about the data? Well, whether it's a corporation that you don't necessarily want to know everything, or the government that you don't necessarily want to know everything. It very quickly, all of these technologies have an ethical thread to them that's interesting, I think. So anyway, uh, yeah, new techniques for machine learning and natural language processing for real-time decision making. Remember that. Read each word and be specific to the directions. Remember, in my academic writing, ATQ, answer the question, focus on the instructions. So make sure as you read these things, you are taking into account all of the nuances of the instructions, because that's what I'll be looking for. Okay, next bullet, number 4. More work is necessary on how to efficiently model uncertainty in machine learning and natural language processing, as well as how to represent uncertainty resulting from big data analytics. Now, to me, that, and I'm not a statistician, I am not a mathematician. I've had two statistics courses in my life. But to me, modeling uncertainty in like inferential statistics, where you are trying to extrapolate a sample to a population. You represent that uncertainty normally with a confidence level. We are, you'll see this in, political polling. Uh, Candidate Smith is ahead of candidate Jones 55% to 45% with a margin of error of 3%. That is your uncertainty that is modeled through uh, pretty much tried and true statistical measures. But how do you represent that? Uh, that confidence level or that statistical significance in big data when you're looking at these different sources, um, with what confidence. And this is cutting edge stuff, guys. This is next level research, and so you're not going to find the answer. You're going to find recommendations and whatnot in those directions, and it's okay to say that this shows promise or that might result in, researchers are enthusiastic that this technique might show promise. A lot of these are next level, so you're not going to find necessarily something that is a perfect solution. So just frame it that way as you're writing, and it'll be fine. Oh yeah, and CI algorithms. I had to look that up real quick. What was that? Collective influence algorithms. This is kind of like going back to the clustering algorithms in machine learning. So that's kind of next level. You'd need to do some digging. Unless you already know what these are, then I look forward to seeing that tackled in your research paper. But yeah, this goes into the kind of algorithms that are used for data mining. Oh, I do need to. I've got a data mining with R session that a colleague of mine put on for me for another purpose, but you guys might find it interesting. I'll make sure and post that this week. Okay, on to the discussion. Okay, this one, there's three things. This is going to be easy, guys. So keep it light. Okay, keep this personal and professional and interesting and discussion. Okay, this is going to be easy to do what I'm asking to do. Uh, um, Again, I shared links before. We don't want to see them in your answer, but they're a good thing to get your brain started. So there's a lot of discussion regarding data analytics and data mining. What's the difference between the two? Provide an example of how each is used. And for goodness sakes, if you can please provide an example of one or the other from where you work or where a friend works or something you read in the paper, or you know what I mean? That would be really great. Like I said, this is papers are academic, discussions should be discussions. There should be a different, you should approach them both differently. Okay, and then explain how you may use data analytics and data mining in a future career. I make these instructions as clear as I can. I don't understand. I don't understand what I'm doing wrong. Like I looked at the Python and R. It's clear in the instructions to include some code samples from each language and in your initial responses. And I'm seeing folks that didn't. It asks you to relate your experience with them. I'm seeing where folks didn't do that. I mean, uh, that's not complex. If it's something, if it asks for it in the instructions, so I'm looking for it. Follow the instructions. This is going back to grade school. So anyway, there. I separated them out by number in this lecture so that you could see them clearly. So that's what I'm looking for this week. As always, if I made some comment in your paper, or I highlighted something, or I gave you a comment in your feedback that you either don't understand or don't agree with, um, please shoot me an email. Let's talk it over. I am available to go over your work in real time, word for word. Um, if you want me to do that, I certainly will. Okay. Meanwhile, on to week 4, and we will be halfway through the course when this week is over. Hard to believe. Have a good week.